right, guys. We are going to start the last section of this chapter. We're going to spend today and tomorrow learning this section. Friday, we'll have a day to kind of practice this section, okay? This is all about finally solving all of this. Everything so far has been simplifying, simplifying, simplifying. We've never had an equal sign. Now we will. We're going to actually be solving things, okay? Today would probably be the easier of the 2 days of solving, but either day, they're not terrible, okay? They're not terrible. All right, so radical equations. An equation with a variable inside a radical is called a radical equation. All right, so far we've had like square roots inside of our equations before. We've had that like back in chapter 4, but now we're going to have different roots in there as well. All right, if the radical is a square root, the equation is called a blank equation. If it's a square root, it's a square root equation. Fancy terms, we don't really, I'm not going to be particular on stuff like this, but just in case you see it or hear it. So for example, there's an example of an equation that we might be seeing. So that's a little different than what we've seen in the past, right? We might have a radical x underneath there or something like in times before, but now we got more stuff that's going to fall underneath the radical. All right, so how do you solve something like this, right? So get the radical blank. What do you think? What? Alone, yeah. Get the radical by itself. That's the first thing you need to do is you want to isolate that radical. Get everything else, all the extra stuff, get it away from it. And then to get rid of the radical, do its opposite. I mean, a lot of this goes back to thinking about your basics of equation solving, right? You always get the x totally by itself, and you do the opposite to get rid of things. What's the opposite of a square root? It's to blank both sides of the equation. What's the opposite? Yeah, it's to square something. The opposite of a square root is to square both sides. All right, then we'll go ahead and solve for x. And then it's a good idea to check your answer. You can plug it back in. If you're like, I'm not sure I did that right, you can always plug it back into the original and make sure it works. Okay? All right, so number 1. So first thing we want to do is try to get the radical part by itself. So what do I have to move? Good. Let's subtract that 6. So we get radical 3x minus 2 equals 4. Can I move that 2 and stuff out of the radical? No. Okay, that's kind of like that jail holding on to it. So I can't just move that out. But how do you undo a square root? You square it. So you're going to square both sides of the equation. Because a square root and a square are opposites of each other, and they're going to cancel each other out. So this is going to be just 3x minus 2. All right, square and square root cancel each other out. And what's 4 squared? 16. Now it should look like something that you know how to solve. Then we'll add the 2. So 3x equals 18. X equals 6. Yeah, times it by itself, same thing as squaring it. How are we feeling with the first one? First one's always the easy one. She's like, I'm not saying anything until we're done. All right, yeah, go ahead and try this one by yourself. All right, let's see if you guys were right. All right, so we need to subtract the 2. Got to get that radical by itself. So radical 2x plus 4 equals 8. How do you get rid of the radical? You square it. And if you do something to one side, you got to do it to the other side. So the square root and the square cancel each other out. 8 squared is. And then solve from there. So we'll subtract 4. And then divide by 2. So x equals 30. I'd say they did pretty good. All right. Moving on. What do you want to do first? Subtract 3. So radical 3x minus 5 equals 5. Not square root it, but square it. Oh, not same thing. Complete opposites, actually. All right, so we get 3x minus 5. 5 squared is? There's too much of a hesitation there. Add 5, so 3x equals 30. Divide by 3. My magical ink, did you see that? I totally just froze. Oh, there it turned red. Wait for it, it'll come back. It's tired this morning. Hold on, it'll turn green. One of these days. There it goes. Okay, there we go. So x equals 10. How are we feeling about these really basic ones? Good. Any questions at all with these? Doing all right? All right. What about this one, though? There's more stuff to get rid of. Do you divide first or subtract first? We subtract that first. Yeah, we need to subtract the 6 first. This 4 is underneath the radical, so it's like off limits. You can't touch that. So that will give us 18. And then how do I get rid of the 3? Good. Then you'll divide by 3. Can I distribute that 3 into my radical if I wanted to? No. Okay. So radical 2x plus 4 equals 6. Good. Then we can do the square thing to get rid of that radical. So we'll get 2x plus 4. 6 squared. There's that hesitation again. Come on, guys. Subtract 4, so we get 32. Divide by 2, and x equals? Good. All right, so that one was slightly harder, right? You had a couple extra things to get rid of. Ramon? Yes? Right, so I mean, leave it as a fraction. Yeah. Yes, you can do this one by yourself. All right, guys, what'd you do first? Subtract 3. So radical 5x minus 6 equals 4. Then what? Square both sides. So we get 5x minus 6. 4 squared? That was a little faster. Add 6, so 5x is 22. Good. If it doesn't divide evenly, just go ahead and leave it as a fraction.
Thank you.
Welcome. Bless you. All right. But how do you solve other radical equations? So you're going to get the radical by itself or alone. To get rid of the radical, do its opposite. Does this feel very familiar to what we just did? The opposite of a radical is an... The opposite of a radical. It's an exponent. So what's the opposite of a cubed root? What was the opposite of square root? You squared. So what's the opposite of square root? What's the opposite of a cubed root? To cube it. The opposite of a fourth root is to... Oh, that sounds funny. All right. So now I have the cubed root of 5x plus 2 equals negative 2. Yeah, so my radical's by itself. So to undo a cubed root, I'm going to cube it. So I have to cube both sides. That's not so bad, right? So we get 5x plus 2. What is negative 2 cubed? Good. So 5x equals negative 10. So x equals beautiful. That's not so bad, right? That's not so bad. Good. I told you, today's not so bad. I might move a little further today into a little bit of tomorrow's stuff, just to, because we're getting through today so fast. Homework today should be easy, though. Sure. You want to do this by yourself? All right. Do it by yourself. All right. What did you do first? Good. Subtract 3. So the cubed root of x minus 7 equals 3. Then what? Good. We'll cube both sides. So the cubed root of x minus 7. No. No. I don't know. X minus 7. All right, I did that to cancel that. I don't know what I'm thinking. Good. That's 27. So x equals 34. I don't know. Not paying attention. All right, how are we feeling with this stuff? Good? Good. What about number 8? What do I do with that one first? Good. Let's add the 5. So 2 cubed root 8x equals 8. Good. And then from there, we can divide by the 2. So we have the cubed root of 8x equals 4. Good. Let's make sure, I want to make sure we're understanding that I can't like cube both sides or fourth, as you guys said, at both sides, unless that radical is totally by itself first. Okay, so make sure we're always getting that by itself first before we do this step. So we get 8x equals 4 cubed. Good, that is 64. Perfect. Next one. That woman's ready to move. I may skip some of these, you know. If we're good, I may skip them. Skip to the homework. Let's skip 9. Let's look at 10 real quick, just so we can see one that has a 4th on it. Good. Subtract 8. So the 4th root of 2x minus 7 equals 1. Good. We have to raise it then to the 4th power since it's a 4th root. Okay, hold on. I know most of you are real excited and flying. I want to make sure I don't lose anybody, though. Okay, so that'll make that 2x minus 7. What's 1 to the 4th?
Don't give me that look.
So add 7. Divide by 2. X equals 4. Good. Good. Homework tonight is go over what I just went over with you. Okay? Yeah, homework tonight's going to be pretty easy. I do want to get part of this in today just so that tomorrow, since we have a lot of time today, that way tomorrow it's going to be that much faster and easier and we'll have more time to work tomorrow. Fair enough? Okay. All right, so the second part, it's really still not terrible. You're going to get now we're dealing with rational expressions, right? It's not a radical, but it's written with those rational exponents. I haven't even showed you how to do it yet. Maybe it won't be bad. Get the rational exponent expression alone, by itself. I was going to say that was yours, Peyton. Yeah, just like we got the radical part by itself, we're going to get the rational part now by itself. Take both sides of the equation to the blank of the exponent. I don't know what opposite of an exponent is. Oh, wrong word. That's not the word I want to use. Reciprocal is the word I was looking for. So the reciprocal, what's the reciprocal of 4/3? There you go. All right, if the denominator of the new fraction is blank, the right side of your equation will be blank. Yeah, wait, what? if the denominator, which part's denominator? Okay, of the new fraction, so once I flip it, is even, the right side of your equation will be plus minus. That's the new part. That's probably the hardest thing to remember today. It's just remembering that. Don't whine. All right, and then make sure you check each answer to make sure it actually works. Okay? So, let's try one of these bad boys and see what happens. So, first thing though is I want to get that rational expression part by itself. So what do I have to get rid of? The 4. Can I distribute that 4 into there? No, do not, because this exponent is kind of holding all of that hostage. So we're going to divide by 4. So we have x minus 3 to the 2/3 equals what? Thank you. All right, now here's where the newer part comes in. So I have to, what am I taking each one to? 3 halves. Yep, you will raise it to the reciprocal of whatever that was. Yeah. Well, hold on. Let's time out real quick. This is actually exactly what we were doing before. Take a time out from this. Because before, if I had, I don't know, like 3x minus 2 underneath here, and that was a square root, how would you rewrite that in the other form? What exponent would that be? 1 over 2, right? The root goes underground. So what did you do to this? You squared it, right? Isn't that 2 over 1? It's still the reciprocal. Technically, you're doing the same thing. Then the question becomes, why does it cancel? What's 1 times 2? And 2 over 2 is 1. It's getting rid of that exponent. It's turning it into a 1. If it's raised to the first power, it's not changing anything. So if I look at this, so really, like this right here is going to cancel out, becomes a 1, which I don't really need. So that's why it becomes just x minus 3. I want to make sure you're seeing that math happening there. You don't ever multiply the coefficient by an exponent. You have a calculator in your hand, right? Type it in. What is 16 to the 3 halves power?
I don't know how to do that. Wait, how do you?
In your calculator, you're going to type in 16. Guys, shh. Stop whining. 16, be nice. 16, caret button raises it to an exponent, and then you're going to put to the 3 halves. All right, raise it to the exponent. What do you get? I'm not that far yet. Now, that one kind of funky rule that we just talked about in the last page, if the denominator of the reciprocal is even. Is that even? Mm-hmm. Then that means this actually is plus minus. So x equals, normally when we had stuff like this, I would just kind of move this over here. So 3 plus or minus 64. What's 3 plus 64? Try again. I'm not doing 64 minus 3. I'm doing 3 minus 64. It's negative 61. Right? Trying to put me in my place. Ramon. So when the reciprocal, the denominator of the reciprocal is even, you actually end up with 2 answers. If the denominator of the reciprocal is odd, you just have the 1 answer. It's kind of strange, I know, a little different. All right, let's try the next one. So what do I need to get rid of or move first? The 12. So let's add 12. 5x to the 1/4 equals 30. Am I ready to raise things to the 4 over 1, or do I have to get rid of something else first? I have to divide by 5. Because I know a lot of you are like, oh, 5x, that's one piece, right? No, 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 it's not one piece. That 1/4 is only on that x because there's no parenthesis holding it to anything else. So x to the 1/4 equals 6. Then what? Reciprocal. What's the reciprocal of 1/4? 4/1 or just 4? So will my answer to this be plus minus? Is the denominator of the new fraction even? No, the denominator is 1, so it is not going to have a plus minus on it. So x equals, what is 6 to the 4th? 1296. You want to try again to read that the appropriate way? There you go. Thank you. Just making sure she was capable. I divided by 5. Because this fractional exponent is only on the x. If this was in parentheses, I'd have left it with it. Right, so I had to get rid of it before I could raise things to the reciprocal. Yeah, it kind of goes back to that whole thing we've been practicing about, does it go under the radical when you flip it into radical form, or does it not? It's the same idea. Let's try number 3. What do you want to do first? Add 4. So 3 times x plus 5 to the 3/5 power. 77 plus 4? Good. Good. Then we have to divide by 3. So x plus 5 to the 3/5. 81 divided by 3? Good. It's 27. Now that part's totally by itself. So now I can raise it to the reciprocal, which is 5/3. Good. It is not even at the bottom, so I don't have to worry about the plus minus. What do I get here? Okay. Subtract the 5. So x equals 238. The denominator, 3 is an odd number. Yep. And again, that plus minus then would go on the 243. Then you'd have 2 answers down here. Yeah, don't just throw it on your answer. Ramon? No, because I'm not going to give you everything today. That's for tomorrow. There's more to learn tomorrow. Let's do this last one, then I'll give you guys your homework. We'll make today a pretty easy day for you. No. Because look at this problem. You have a couple options here. I see a lot of you writing feverishly. What are you doing right now? Subtracting 7? Okay. Let's go through here. A couple things are going to happen, and you have some options. 71 minus 7? Then what'd you do? And then you got stuck. All right. From here, you have 2 options. My personal preference is I would flip this back into exponential form. That's what I would do. Because all I'm doing at this step is I'm rewriting. Which one's the root? The 3. And the 5 would be up top. That would be option 1. And now it looks just like the ones we just practiced. So what would you raise this to then? Is the denominator even? No, 5 is an odd number, so don't worry about plus minus. So you'd get x plus 2 equals, what is 32 to the 3/5 power? Would you believe me if I told you that I could do that in my head? I hope you believe me, because it's really not that hard. To make sure, I want to explain to you, because some of you I know would like to do things in your head. This little 5 in the denominator means the 5th root. What's the 5th root of 32? It's 2. because right, 2 times 2 times 2 times 2 times 2 is 32. So then I'm doing 2 cubed, which is 8 in my head. So that's, if I'm doing these in my head, that's what I'm doing. I'm taking the 5th root of this, and then I'm cubing that answer. It's the same idea. If you want to use a calculator, by all means, but I want to make sure you understood that you can do those things in your head. Can I show you real quick the other way to do this? I'm sure someone at some point will do it. You'd start the same way. So once you get to here, cubed root of x plus 2 to the 5th. I said you had two options. One is to flip it into the rational exponent. The other way is, how do you undo a cubed root? You cube it. So undoing this would get rid of that, but I'd still have x plus 2 to the 5th. What's 32 cubed? Somebody's got to read me those digits. 700 and what? 68. Thank you. All in unison class. And then how do you undo a 5th to the 5th power? You would take the 5th root. Or you could do the reciprocal. Either way, it's the same idea. So you'd get x plus 2 equals, what's the 5th root of that big number? I'm going to say 8. Am I right? So you got x equals 6. So, I mean, you could go either way. To me, it's simpler just to flip this real quick into the fraction, do the reciprocal, and I'm done. But either way works. Okay? We'll go ahead and stop there today. We'll kind of pick up with this tomorrow. We'll do a little more of this kind of stuff, and then some where you end up with extraneous solutions tomorrow. Extraneous.